Hi, and thank you for coming to this talk. I'm truly honored to be presenting along with all the other talented and respected individuals at the conference today. So thanks for attending. This talk is entitled Behold, the SBOM, Practical and Strategic Advice for Making SBOMs Work for You. Quick introduction before we dive in. My name is Steve Springett. I am the leader of the OWASP Dependency Track project. It's a project specifically designed to consume and analyze software bill of materials. I'm also the chair of the Cyclone DX core working group, which is a software bill of materials format. I'm the leader and co-author of the OWASP Software Component Verification Standard, which allows organizations to measure and improve their software supply chain assurance. I'm one of the contributors to the package URL specification, which is really good at identifying or having an identifier for open source components. And I participate in multiple transparency working groups for the federal government. What I actually get paid to do is software security architecture at ServiceNow. So before we dive in, let's just level set what is an SBOM, right? At a very elementary level, this is what it is, right? It is a list of ingredients. Now, in this particular example, this is an energy bar, right? And the idea here is that if I am allergic to, say, peanuts, well, this provides me a way to make really informed risk-based decisions. So SBOM is kind of like that, except for software at its really fundamental level. Now, there's some really great talks, some recent talks. There was one at KubeCon that I would highly encourage everyone to take a look at. It's both entertaining and informative. So check that out if you haven't checked out this talk before. One of the primary reasons why we're talking about SBOMs, however, is for vulnerability management use cases. A lot of software companies are not exactly are very opaque in the types of components that they ship in their software, and the executive order 140.028 kind of mandates SBOMs for all federal government purchases, right? So a lot of the reasons why we're talking about this is for vulnerability management purposes. And with that in mind, many of the technical requirements for the executive order was shifted over to NIST. However, NTIA, or one of the sister agencies of NIST, was responsible for describing what the minimum elements of an SBOM are. And this is essentially what they are. You have a supplier name, the component and version, right? Maybe a few other unique identifiers, dependency relationships, timestamp, and who authored the SBOM. Really, really minimum fields. However, minimum fields equals minimum benefit. Now, keep in mind that this is the minimum elements, not of all SBOMs, just SBOMs going to the federal government. Capitalism has a tendency to kind of flesh things out a little bit more. So from a purchasing or M&A perspective, I would expect most companies to demand a lot more in their software bill of materials than just the minimum elements. I know I do when I procure software or when I buy a company. So minimum fields, minimal benefit, but what else should you care about? Well, there's a lot of different things that you probably should care about. And we'll dive into very, very briefly what these things are. First one is authenticity. In other words, did someone actually create this component, right? And is it digitally signed, for example? There's a lot of different use cases around authenticity that you can describe in an SBOM, right? Especially for very complex component assemblies where you might actually get a component that includes other components from a different supplier, and then you digitally sign that and then include that in your overall inventory of the SBOM. There's all kinds of authenticity requirements or use cases that you can do with an SBOM. Integrity verification. Well, what is integrity? That could be a lot of different things, right? There's a lot of security use cases for both authenticity. There's a lot of security use cases for integrity. In this particular case, I'm referring to, has something been tampered with? Has a component within your inventory been tampered with? Has the SBOM itself been tampered with, right? Is it the same as what I expect? Now, services also are really, really important in a bill of materials, right? Software does not live in a vacuum. It hasn't lived in a vacuum for 2 decades, right? Software calls out to the internet. It phones home to update or provide some kind of service to you, whether it's a desktop application, server, IoT appliance. Many software calls out to the internet. And those services are absolutely part of the inventory. And I care about these services. Now, vulnerability remediation is also really important. And I'll give you a good example of this, and a really recent example, actually. H2 is a very widely used embedded database platform, right? It's written in Java, but it's used by millions of organizations. Now, recently, there have been a string of high severity vulnerabilities against H2. Now, the project has a history of not actually backporting security fixes, right? You have to upgrade to the latest version, as is a lot of open source projects. However, the latest version has breaking changes. Therefore, organizations are forced to choose between, do I break my application and nothing works, or take the risk of having a high severity vulnerability that somebody may or may not exploit? Well, guess what? The vulnerable component is actually the least risk. So organizations, at least responsible organizations, are now backporting their own security fixes to remediate otherwise vulnerable components. And your SBOM should absolutely be able to describe this. Now, your inventory of components also should be able to describe, do those components have any security advisories against them, right? Whether it's, Red Hat security advisories or JBoss or, whatever the case is, right? Your inventory is more static in nature, but your vulnerability information is going to be very dynamic, right? It's very fluid. It's going to change all the time. And there's several different advisory formats in existence. CSAF out of OASIS is certainly one of them. It should be ratified in the next couple of months. Version 2 is really what they're striving for. Cyclone DX is also an advisory format, and there are a few others as well. Being able to describe what the vulnerabilities are in a given piece of software is also kind of important, right? If I have a piece of enterprise software, if I'm a consumer of that, I want to know what those vulnerabilities are. And that can be decoupled from an SBOM, but it's a complementary artifact to the SBOM. Now, this one is really, really important. How complete is the SBOM, right? Do I have the complete inventory of components? Do I have the complete dependency tree? Do I have the complete inventory of services, right? These are all things that I can describe in an SBOM. Pedigree. Now, pedigree, this refers to the DNA, right? What is the makeup of this particular component, right? Especially for modified components, I might start out with an original component like that H2 example. I make my modifications. I can describe what that pedigree is, right? I can describe what were my changes, what were my commits, what were my diffs, what was my original component, who made them, and why? What security issues am I actually fixing with this thing that I'm now creating, right? This derivative of H2. I can describe that in an SBOM. Provenance. Provenance is also really important. This is a story of origin. And provenance could refer to a lot of different things. For example, it could refer to the repository in which I obtained a component from. It could refer to the country of origin of that component. It could refer to a given supplier or manufacturer of a component. And finally, security isn't the only use case, right? There are other non-security use cases, for example, license compliance. That is important. And of course, there are many more use cases for software bill of materials. So in this talk, we're going to be focusing on some of the ways that you can create SBOMs and some of the benefits and drawbacks of the varying approaches. And there's more than one approach to creation of SBOMs. In fact, there's many, and there's probably many, many more that are not on this slide. And we're going to go through these a little bit at a time. One of the easiest ways, I think, to create an SBOM is using your existing SCA tools. Now, SCA, or software composition analysis, is an entire category of products. It's recognized by the market research firms, and there are many commercial and open source options available. This is probably the easiest on-ramp to creating software bill of materials. The vendors and the commercial tools and the open source tools in this space, many of which already produce SBOMs today, the ones that don't certainly will be in the future. So if your vendor does not support SBOMs or the SBOM format of your choice, talk to that vendor, right? It's in their best interest to support it. Build lifecycle integration. And notice I didn't say build integration, and that's on purpose. Every build, especially for things like Maven or NPM, they have a given life cycle, right? Your build goes through a series of phases. And at different phases of the build lifecycle, your dependency graph and your component inventory is actually going to change. So it's really important, I think, to be part of that build lifecycle. In my experience, being part of that build lifecycle as opposed to external of that lifecycle yields the most accurate and comprehensive inventory and dependency graph that you can create. For example, Maven has different phases of its build lifecycle, and your test dependencies, for example, are not actually resolved early on in the lifecycle. Likewise, you have things post build, for example, using the Maven assembly plugin, right? That could add additional components or strip components away. So being part of that life cycle is really important. Another example is NPM, right? Your lock file is a strong suggestion, essentially, but your lock file does have a way of lying to you. One lifecycle thing that I like to call out on NPM specifically is really about distribution models, right? If you are distributing something to a web browser, are you really using everything in that lock file? No, of course not. You're going through something like Webpack that's going to strip 2/3 of all those components out, leaving you something that's much smaller, that's much more easy to send to a web browser, and of course, faster for that web browser to interpret. So being part of that build lifecycle is really important if you want to produce an accurate bill of material. Source, you can describe just the source files as well, right? Not a whole lot of security use cases for this. There are a few, but mostly this is for license and intellectual property use cases. Now, one of the, I think, biggest examples of source SBOMs was the Kubernetes project. That was their original SBOM that they created. So congratulations on the Kubernetes project for doing it. Not overly useful for vulnerability management use cases, however. Hopefully they've corrected it since then. I personally haven't had a chance to look. But again, knowing what your target audience expects from your SBOM is kind of going to lead you to one of these various methods. This one is really, really interesting. So you can create SBOMs at runtime using IAST tools or using mobile tools, for example. This is really interesting because you might have an agent running on your app server, whether it's a Java app server, .NET, Chrome V8, whatever the case is. You can actually create these SBOMs dynamically, not only of the software components, but of the services that those components reach out to. So you get a more comprehensive view of your inventory with this approach, which I find really, really interesting. The same tactics can actually be used for mobile apps as well, both iOS and Android. Build factory integration. This one is really interesting because it allows you to target thousands of builds at the same time, right? If you're using something like Circle CI or Jenkins or GitHub Actions, right, you can target it at the factory level itself. Therefore, all of your builds using the factory will then be able to produce SBOMs. Will they be accurate? Will they be exactly what you want? Maybe, or maybe not, right? You might actually have to go that one step further in actually integrating into the build lifecycle itself. But build factory integration is a really easy way to be able to scale up producing SBOMs, within your enterprise. And finally, hopefully nobody has to do this, but manual authoring is a thing, especially for languages like C and C++, which for the most part, haven't really taken advantage of best practices or package management options that have been available to them for well over a decade, right? Many C and C++ projects continue to manually manage their dependencies, manually make modifications to those dependencies, and are now expecting automation to solve their SBOM problems. It's not, right? You have to manually also author your SBOMs, unfortunately. So the reason we bring all this stuff up is that you choose the format and the approach that is really right for you, because we don't want you to be this person. And finally, garbage in, garbage out. This should be very self-explanatory, right? You start with some good data and you target the audience and what they expect for the SBOM. That way you really have the best you have the most useful information in that SBOM for the consumer of that SBOM. So we're going to take a few moments and talk about Cyclone DX. Cyclone DX is a bill of materials standard, and we're going to talk a little bit about it and how it kind of relates to some of these things that we just talked about. Real quick, and there's a lot of data on this slide, so I apologize for the information overload, but I think this gives you a really interesting overview of the capabilities of the standard, right? If you look at the components, right, there's a lot of different components that we can describe, from applications and libraries and frameworks to operating systems, firmware, and even hardware devices, right? So Cyclone DX can handle a lot of different use cases. Services, because again, software doesn't live in a vacuum, right? It communicates to the outside world, so we can describe what those services are, who the providers are, what the data classifications and the directional flow of data, and trust boundary traversals, and any authentication requirements as well. Dependency relationships are obviously part of that, not only for the software components, but for the services as well. So if you have a component that relies on another service, you can describe that dependency relationship. Likewise, if you have, for example, a microservice architecture and you want to describe a microservices dependency on another microservice, that's fully supported use case as well. Compositions, this is really how complete the SBOM is, right? Vulnerabilities, this is for a lot of security use cases, obviously, but being able to support advisory use cases and being able to support something called VEX, which is what we'll talk about in just a bit. And there's a lot of ways that you can customize or use Cyclone DX outside of the capabilities of the core spec. But SBOM itself is interesting, but SBOM itself is a crawl behavior. If we're looking at crawl, walk, run type of analogies, SBOM is really a crawl behavior. And the minimum elements that we described earlier on, that's kind of the equivalent of, maybe a toddler or baby lifting its head for the very first time, right? But SBOM is just one of many, many things that we as security professionals should actually care about. So SBOM, as we've been talking about, is really about the inventory of my components and optionally my services as well, right? But there's other kinds of bill of materials. For example, operational bill of materials. OWASP is actually a BSIM behavior, right? There's lots of organizations actually doing OWASPs today. And how OWASPs differ from SBOMs, imagine this. Imagine you get a piece of software for a vendor, whether it's a commercial vendor, maybe it's an open source project, doesn't really matter. It's an SBOM. And now you deploy it somewhere, right? You deploy it to an operating system, you deploy it to a container, you deploy it to a Java app server, right? Well, that deployment actually has its own bill of materials, right? It has an operating system. It might actually have a Java servlet container, and that Java servlet container might actually overwrite the dependencies of your SBOM, which is a supported use case, right? So now your OBOM actually can affect your SBOM in terms of the effective inventory that's in play at runtime. So OBOM is very, very important. Manufacturing bill of materials. This is really for hardware devices, right? In the physical world, they have lots of different bill of material types. In fact, they have the bill of material types for procurement or procurement bill of materials, right? What is the bill of materials of what I need to buy? They have engineering bill of materials or EBOMs. These are things that might contain CAD drawings and other things that go into the design of a particular thing. Then, of course, you have MBOMs or manufacturing bill of materials. This is really the end product, right? What is the as-built thing, including optionally all the packaging material around that thing. In addition, it might also contain the formulation or the recipe for how that thing was built. So MBOM is a thing within the physical device arena. In the cybersecurity world, we incorrectly refer to this a lot of times as HBOM or hardware bill of material, but in reality, it really is an MBOM. SBOMs. SBOMs are in fact a thing, and it's been supported by Cyclone DX for several years now. In fact, there's multiple commercial and open source tools that actually support SBOMs. And what SBOMs are essentially bill of materials that describe nothing but your services, right? There's no software components in there. It's just your services. And where this really is beneficial is complementing things like infrastructure as code, right? Infrastructure as code really describes the layout, right? How things are laid out in your virtualized infrastructure. Your SBOM actually describes the consumption of those services, right? So it's a very complementary type of logical representation of these services that others might consume. And your services, of course, can consume other services and be part of that dependency graph. And your SBOMs, for every single service in your SBOMs, every service can then refer to its corresponding SBOM. So you get this whole holistic view of your services and a logical view of that, as well as your bill of materials or your software bill of materials for every single service within your SBOM. So this is a supported use case, and it's formally recommended by the Cloud Security Alliance. VEX is a really interesting use case. Now, Cyclone DX supports advisories, right? It is actually an advisory format as well. VEX is actually the anti-advisory format, if you will. So advisories are going to tell you what something is vulnerable to, right? I might have that H2 thing, for example, that H2 database, and it has a bunch of advisories against it, right? This is true. But the VEX will tell me if I'm using H2, for example, and I have some mitigating controls, or maybe the code is just not reachable for whatever reason, I can actually describe in a VEX or vulnerability exploitability exchange that my application might actually be using this vulnerable component, but because of mitigating controls or whatever the case is, my application isn't actually vulnerable to that component. Now, depending on who you talk to, between 80 and 90% of open source components that are vulnerable are not necessarily exploitable, right? And that's really a key benefit of VEX. So it's going to tell you what something is not vulnerable to. And of course, there's many other types of bill of material things that you can do with Cyclone DX. Now, it is in use in production at an estimated 100,000 organizations. So we've been doing this for several years now, starting back in 2017. But we estimate based on the number of downloads of all the different Cyclone DX tools, of all the security vendor support that this format has, as well as the millions of downloads of OWASP Dependency Track, which is a platform dedicated to the consumption and analysis of Cyclone DX SBOMs. We estimate that there's around 100,000 organizations doing this today. Now that's an interesting number, because 100,000 says, to me anyway, that this is real, right? People are operationalizing this stuff today, and there are tools and to produce the SBOMs, and there are tools to consume and analyze them, right? Lots of folks are using this today. But in relation to the millions of organizations that exist, it's still a relatively small number. So this is really the call to action, right? Teaching you a little bit about SBOMs, and hopefully you'll have a little bit more information to go back to your respective organizations and put that on the roadmap for hopefully this year, right? The Cyclone DX website does have a lot of use cases for what it can, the format can be used for. We're not going to go into all of them, but I highly encourage you to check out the website. There's examples in both JSON as well as XML that I invite you to take a look at. We also have, and it's not on the slide, we also have in our GitHub repository, we also have a SBOMs examples repository, and it has examples for SBOMs, SASBOMs, OBOMs, VEX, MBOMs. There's examples for all of these different use cases in our GitHub repo. So take a look at that as well. The Cyclone DX Tool Center, I think we are up to close to 100 different tools. These are just the tools that are known. There's, in reality, there's certainly over 100 tools that out there that support the standard. But again, no matter what you're looking for, there's probably a tool out there to do it. For example, if you are in the Go ecosystem, there's not just one, there's multiple choices to choose from. So not just the Cyclone DX tools, but there's other vendors' tools also supporting Go that you can use. So there's a lot of choice in the Cyclone DX ecosystem. Right now, we're focusing on some of the more obscure things like R, right? Not overly popular, but still really, really useful. So we're targeting some of the lesser known languages as well. And if your language or ecosystem is not supported, understanding and creating a fully compliant Cyclone DX implementation is actually really simple. It's not hard. Most people can read the spec, understand the spec, and implement the spec in about a day, right? It's not overly difficult. Here's some links for community participation that I encourage you to check out. Our website, obviously, our GitHub repo that I was mentioning, take a look at that. Again, there was that SBOM/examples that contains all the different examples for the various types of bill of materials. We do have a pretty vibrant Slack community, so take a look at that as well. The invite is in the slide here. OWASP, or excuse me, Cyclone DX is a flagship OWASP project. However, for historical reasons and for just the sheer number of channels that we have a separate Slack workspace outside of the OWASP. So if you are on the OWASP Slack workspace, just know that the Cyclone DX channels are independent of the OWASP channels. We do have a mailing list, right? We have a lot of our friends in the federal government, for example, that typically cannot access Slack for various reasons. So we do have a mailing list. We use Groups.io for that currently. And we have a couple links for our socials as well. So LinkedIn as well as Twitter. And we highly encourage you to take advantage of these social aspects as well, because we want to hear your success stories, right? We want to hear what works and, more importantly, what doesn't work. So take advantage of our LinkedIn, our Twitter, and of course our Slack workspace to provide some feedback. And more importantly, if you're interested in this kind of standard, right, get involved, right? Anyone within the community can participate in any of the OWASP projects, including Cyclone DX. So if you're interested in this kind of content, this kind of standard, highly encourage you to get involved as well. So with that, I thank you so much for attending. Hopefully this was beneficial to you, and have a great rest of your day.